Okay, let's solve this one. Aeroplane land on a runway with speed is equal to 180 kilometer per hour. Do not forget to always convert 180 kilometer per hour to do not forget to always convert 180 kilometer per hour to meter per seconds. That is 180 times 1000 abi over, right? 60 times 60 can cancel without pressing calculator. What else we cancel? I can cancel without pressing calculator. This cancel, this cancel. So what do I have now? This go here, 3, 2 go here, 5, go here, 1, go here, 30, go here, 1, go here, 10. 5 times this is 50, right? Meter per second. So if that is so, then time is 30 seconds. These two give us what we call the acceleration. Remember that? V over t. So that is 50 over time, 30. 5 divided by 3 is 1.67 meter per second square. So what do we have now? So they're asking us distance covered. S is equal to ut plus at square over 2. We have used the velocity to find our acceleration. So S is equal to 0 times t, 1.67 times acceleration, 1.67 times t is 30 square over 2. So S is equal to 1.67 times 900 over 2, which is equal to 751.5. So what is the closest meter here? 750 meter. That is the answer. Okay, a motor vehicle is brought to rest from a speed of, here, they're not asking you distance after applying the brake, but it's automatically brought to rest. So if it's brought to rest, final velocity has become 0. Initial velocity is what? 15 meter per second. Time is what? 20 seconds. Remember V is 0 because it is brought to rest. So calculate the retardation, which is acceleration. V is equal to, which formula is going to go here? V is equal to U plus AT square over 2, right? So 0 is equal to U is 15 plus A, which we are looking for, times time 20 square over 2. 0 is equal to 15 plus 20 square is 400 A over 2. So this cancel is 200. So we have 15 plus 200A. 200A come over here over 15. Divide by 200, divide by 200. I press 15 divided by 200. 15 divided by 200. So the answer should be 0.075, not 0.75. This is a velocity time graph because here is velocity, here is time. So the diagram above represents the velocity time graph, yes, of a body in motion. The total distance traveled by the body is 195 meters. I want you to take note of this. If you have a velocity time graph, the total distance traveled by the body is the area under the graph. If you calculate the area of this trapezium is the area under the graph. If you calculate the area of this trapezium, it's going to give you 195. Then calculate the acceleration of the body, not deceleration. This is the acceleration. Why this is deceleration? Here is constant. That from here to here, there's no change in velocity. So acceleration from here to here is 0. So we have to calculate the acceleration OP from here to here. Do we know the velocity at this point? We do not know. So, but from starting point, it started from rest. Initial velocity is 0, is it not? So they're asking us to calculate the acceleration of the body. Acceleration, we are asked to calculate. At this point, what is the time it traveled? The time is 6. So then What's the distance from here to here? The distance from here to here is what? The distance is not 195. The distance of all of them is what is 195. But distance from here to here is not 195. So, but from this 195, which is the total distance, we can know our velocity. Is it not? Yes. From 195 meter, we can know our velocity. If the total time is what? Total time is 21. So velocity is distance over time, is it not? Is it not? So velocity, what is the total distance? 195 over what is the total time? 21. 195 divided by 21. So 195 divided by 21 is 9.2 meter per second. So here is 9.2 meter per second. So if that is so, we have known our V to be what? 9.2 meter per seconds. So now, how do we know A? V is equal to U plus AT. V is 9.2 equal to 0 plus A. We are looking for times time. Time is 6. So what are we going to have now? 9.2 is equal to A times 6 is 6A, right? Divided by 6, divided by 6. So A is equal to 9.2 divided by 6, which is 1.53. Okay, look at this question. Here, the question is to calculate the total distance traveled by the body in this graph. To calculate the total distance, I've told you that the total distance is area under the graph. So we have in this graph is a trapezium. This is a trapezium. This is a rectangle. This is a triangle. In this trapezium, I have the two bases here to here and here to here. So that is total distance is simply area of trapezium. Trapezium is A, B is rectangle, C is triangle. Area of A plus area of B plus area of C. Area of the trapezium here is half base, half A plus B times height. This is the height. This is the two base. Plus triangle is length times breadth. Rectangle is length times breadth, while the triangle, the last one here, is half base times height. So here is half A. First base is here to here, which is 10. Here to here is 20 times height. Here to here, which is 5. Is it not? From here to here is 5. Plus length. From here to here is the length. The length is 5 to 10 is 5. Here to here is the breadth, which is 20. Plus the last one, half base times height. What is the base? 10 to 15 is 5. What is the height? From here to here is 20. So what do we have now? 10 plus 20 is 30. 30 divided by 2 is 15. Is it not? So 15 times 5. 15 times 5, this is 30, which is 15. 15 times 5 is 75, right? Is 75. Plus 5 times 20 is 100. This cancels this 10. 5 times this is 50. So add everything. What's it going to give you? 225. So 225 is the answer. I hope you understand what I solved. This is the area of trapezium. I can change this trapezium to be like this. I can decide to bring this out. It will look like this. If I bring it out, it will look like this. Is it not? This, I can change it to be like this so that you understand very well. This is here. This is here. This is here. Here is this place. Here is this place. I can change it to be like this for a better understanding. It can be like this. It can be like this.